So here's the one of the question a lot of people probably mess up. First part is a is negative 1.5. B is 5. Do you know why it's 5? Yes.
I'm gonna say it's 5 because the total area is actually scratch that. Forget that already.
Okay, Miranda.
Doesn't it say something like? It says something in like I think it was. It said that B was like 3.5, and then since you do B minus A, and A is 1.5, 3.5 minus negative 1.
Yeah, so I will write this out. I will write like this total area under the curve from 0 to 6 is equal to 0 to 2 to 2 to 6. I'll write this out. I'll write this out. And then I'll write down says this is 3.5, this is negative 1.5, even though area is 1.5, but the integral is negative 1.5. So you move the 1.5 to the other side, you get 5. Anybody got it wrong? No? If you got it right, then it's good. Okay, C, you should get 6.5. Because absolute value of something, it's going to be positive. So I here is 1.5, and the 1.5 plus 5 is equal to 6.5. Everybody's okay? For D, you should get 3. For E, you should get 15.5. And for last one, you should get 7 over 12. 3.5 over 5 is just 3.5 over 6 is just a bad notation. It's you're not supposed to have decimal over fractions.
Let's read the question for me.
62.
Oh, okay. That's my one.
That's not a proper notation. You're not supposed to have decimal in a fraction. So you can multiply 2 and top and bottom so to get 7 over 12. Yeah, the proper notation, you should not have a decimal point inside the fractions. It just doesn't make sense. Are we doing okay so far? How many of you guys got everything right? Okay, nice. How many you missed one? Apple, what you miss it? What?
I did C wrong.
C. Okay, so do you understand absolute value? Make it the negative part of the graph above.
Yeah, because I originally I just put 5.
Okay.
Yeah, I forgot to add the 1.5.
Oh, okay. 0.5. Yeah, because it's 0 to 6. Damien. E. E is the integration with 0 to 2 of 2, and that's 12. And 0 to 6 they already give it to you, or you already found 3.5, so it's the answer is 15.5. Okay, so this is one of the question that some of you guys I handwritten this one. Dy dx 2 square root of x, they give you a 0.412. And then you're gonna get a value of c. C is equal to 4 over 3. And that should be your answer.
I got negative 17. What?
I got y equal to 4 third x to 3 over 2 plus 4 over 3. Olivia, did you got it? You gotta find the C. Because there was a point 412, you had to find the value of C. That's why you need to write down plus C when you do indefinite integral. Yes. This is a indefinite integral because there's no boundaries. Because we are taking integral, that's it. We're not looking for which bound to which bound. Yeah. That both C's cancel out. Okay, so this is an this is another one is 5 minus absolute value x, draw it out. If you draw it out, you find out a triangle upside down, and you see is the right part of right triangle is the right triangle. Okay, so question 7, I think it's this one, right, Winston? Question 7. Yes. You graph it. You graph 5 minus absolute value x. So that makes absolute value x is negative, absolute value is facing down, it's moving up.
Moves up just 5.
Yes, Marina?
Do you have to graph it? Because I just took the integral. And then I got it. That's what I did for. Like, how do you
Yeah, but yeah, I disagree with that because if you were to integrate from negative 5 to 5, you would get it wrong. You would have a wrong answer because you will have 0. No, you will not have 0. You will have 2 times bigger than actual value is. So no, I think you should graph it. Anytime absolute value, you should always graph it.
So always graph it.
I always graph it because you can find slope, you can find area under the curve, so much easier to find those things. Because if I change my boundary from negative 5 to 5, then your answer will be take account into this, but supposed to be only in the bottom. But you will have this part, you have double the more amount. So you gotta be careful with that because 5 minus x is just straight line. You're gonna have extra section of area you don't belong to. So it's risky. In this case, you got lucky because the question didn't ask the other side of it. If it asked the other side of it, so let's say negative 1 to 5, you would have wrong answer. Negative 5 to 5, you would have wrong answer. So you have to not take integral just based on 5 minus x. You have to worry about its absolute value. This is a question 7 that Winston had a question about. So every time if I write down, if I see the biggest one from negative 2 to 10 has the biggest thing here, what you're gonna do is you're gonna write out 2 separate integrals from negative 2 to 5, 5 to 10. Does that make sense?
Yeah.
And if you write that, negative 2 to 5 is negative 2. So you just move the negative 2 over, you're gonna get 19. This one's on the test, Max. Be more mature.
Yeah.
Yeah,
Wait, so the answer is just 19.
answer's 19.
Wait,
Yeah.
but I didn't get it. Like, I felt like I was still missing a piece.
No, so you know the longest piece of area is 17, right? But you also know from negative 2 to 5 is negative 2. So you break up to two pieces. One big piece of area, you break down to 2 piece area. From negative 2 to 5, 5 to 10. And we know from negative 2 to 5 is negative 2, so we just move the negative 2 over to get 19. It just write it out.
Oh, okay, I did that. I was confused about it.
But question 8, you should get positive 14. That's the answer. I don't know if you got positive 14. If you write it out like this, you move over, but the question is asking from 3 to negative 4, so you had to change from negative 14 to change to positive 14. So this test is on AP exam. It's definitely on my test. And test is tomorrow, in case you don't know.
Yes, we know last week.
Sensei here.
Thank you, Sensei.
Okay, so can I talk about today's stuff? All right. Today's stuff is fundamental theorem of calculus. Am I still streaming? Oh, screen's locked. Stream. I will not say that, but okay.
Why are you teaching us the day before the test?
Because this test question will occur multiple times, so the smartest thing is always learn the first day. Like, and pay attention on the first day. It's so much a better investment to try to learn it the first time rather than try to learn it later, because a lot of you guys try to learn it later. You just put it off. It's actually really bad. The best way is to figure out the thing. Anyway, all right. So let's talk about fundamental theorem of FTC. Stand for fundamental theorem of calculus. So if an integration of a to b of f of x dx is always equal to f of b minus fa. You do that for the past few days. Integral between two values. Does that make sense? Now, what's FTC part 2? The way I kind of give analogies like this is, if you take a hammer and nail and you take the nail and you hammer into the wall of something, if the situation's perfect, you can completely take out a nail by using the other side of the hammer. Does that make sense? You can have a hook and you hook up the nail. But if you are like perfect handyman, you can take out a nail like straight. You know what I'm talking about? Mm-hmm. But if you're like me, when you pull out the nail is going to be crooked. So why is that analogy is like this? So I'm going to show you the perfect situation first. The perfect situation for FTC part 2. Now remember, this is going to be on multiple part of the test. So it's going to be on this part of the test, it's going to be on next part of the test, it's going to be on like multiple part. So FTC part 2 basically says, hey, I want to take a derivative of a function that's integral between 0 to x of f of x dx. So I'm taking derivative of an integral. Obviously, by looking at this, you can say, well, that's very easy. If you hammer in the nail, you take out a nail, it's going to be a perfect nail. So this is a perfect situation. So obviously, that's just going to be equal to f of x. Does that make sense? Because you take an integrate and you take a derivative, right? However, that's a perfect situation. Whatever perfect situation here is, you have an x and you have a 0. First thing first, if you ever have the expression and not a number on one of the intervals, they will usually ask you derivative of it. They will not ask you to find the thing. They will actually ask you to find derivative of it. So if this is expressions, one of them is the expression, which is like x, sine of x, cosine of x, e to the x. Then they will usually ask you the derivative of it. Now, I'm going to show you the slow motion of this question. This question, according FTC part 1, it's just gonna be f of x minus f of 0. And you're gonna take d to the dx here of this. So now after you take a derivative of the capital F, what am I gonna get? Small f of x. Does that make sense? However, the slightly tiny thing more. This is the perfect situation. That's what I'm saying is perfect. If it's not x, if it's just an x squared, then you have something else. So you have to pay attention. There has to be a chain rule. So it has to be chain rule. So that means it's gonna be derivative of the x, which is 1. Most people is gonna miss this 1 and don't think that's significant, but the 1 is super significant. This 1 is super significant because it's gonna be minus f of 0 times 0. Well, anything times 0 is 0, and that's why it's equal to f of x. However, the question I'm gonna give it to you, the boundary is not x. The boundary is gonna be like some other function besides x. So what I'm saying is, I got this question from a student. And this student, I still remember her name. She's from Haiti. Her name is Sarah Godron. She went to University of Chicago. And very good university. When I first met her, she had 520 on SAT math. And the first 2 weeks of the algebra week, she learned all the algebra within the first 2 weeks, and she learned more. So at end of that year, she take a SAT. She got 760, went from 500 to a 760, a 260 points increases. And she make it. She earned Questbridge. She got into University of Chicago. And when she was at University of Chicago, she texted me. She's like, Mr. Yu, I have this question. I cannot do it in my Calc 1 class. I said, you already take Calc 1 with me. Why you still need this? He's like, well, I remember you told me this, but I don't remember the answer. So the question goes like this. Was f of x is equal to integration of cosine of x of sine of x. And the square root of 1 minus t squared dt. And the question says, hey, what is f prime of x? Question mark. Okay. So, and then I said, oh, that's a really cool question. Can I steal it? She said, yeah, whatever, just help me solve this problem. So I help her work it out. But if you realize if it's f prime of x, that means I need to take this function and I need to take a derivative, right? So that means I need to take a derivative of this function and also need to take a derivative of this side in order to get f prime of x. However, you're gonna say, hey, I don't think you have ever taught me how to take integration of this. But we kind of did, but it's the finite situation. Let's say it's from one boundary, from 1 to -1. You know how to find area. But it's from one bound to another bound. That's expression. So honestly, my BC student, as of right now, today, they don't know how to take integration of this because they don't have proper skill. If you go ask, like, Lucia, if you go ask Christian, they don't know how to take an integration of square root 1 minus t squared because they don't have proper skill for it. So Jacob, pay attention because this is the part that's really, really, really important. So what we're gonna do is, since we don't know how to take integral of something, we're gonna use notation to substitute. And notation to substitute, then you say, well, I'm gonna assume this is equal to g of t. So we're gonna write down g of t is equal to square root 1 minus t squared. I did not do anything different. I just said, hey, I'm gonna assume that function. We don't know how to take an integral. We're just gonna give you that situation of g of t. And it's equal to d to the dx of, again, do you see this is the boundary? That's the term equations. You have to pay attention because they usually ask you for its derivative of it. So this is g of t dt, and this is going to be sine of x and the cosine of x. Because I don't know how to take integration square root 1 minus t squared. We change the notation. We change the g of t, but we know how to integrate the notation. What's integration of non-capital G? What's the integration of non-capital G? Capital G, right? Capital G of x, right? And the d to the dx still there, right? And the boundary is still there. The boundary is sine of x over cosine of x. And I'll just plug in. I'll just plug in d to the dx of big G of sine of x minus big G of cosine of x. Remember, I didn't know how to take an integral, but I know how to take integral of from a non-capital G to capital G. Why does it matter? It doesn't matter because I'm going to take a derivative after that. Except derivative does involve a chain rule. So if you take a derivative of this, there is a chain rule. There is a first circle here, and there is a second circle, because people usually forget about chain rule. So then that's going to give you a g of sine of x times derivative of sine of x, which is cosine of x. Is that okay? Yeah, take a 2 layers. So there's an outer layer, there's an inner layer. Minus g of cosine of x times negative sine of x. Wait, I didn't take an integral of square root 1 minus t squared. So I convert it to a notation. I integrate it, and I take a derivative. So I use that as a leverage because I don't know how to take integrals. Because we know the following is derivative. But the problem is this, people forget chain rule all the time. That's why they screw up those questions. So then all you gotta do is go back and look at here and say, okay, yeah, what is g of sine of x? We'll just plug in sine of x. Replace the t. So 1 minus sine square of x cosine of x minus square root 1 minus cosine square of x. This is plus sine of x. Why? 2 negative sign becomes plus. So that is equal to square root of cosine square of x cosine of x. Do you know why that? Because integration 1 minus sine square is cosine square. And that's square root of sine square of x times sine of x.
Wait, you plug that in for t?
Yeah, I plug in this for t. I plug in sine of x into t. Because this is the function I assume with. That's g of t. That's what we had before. Now, okay. What's square root of square? It's just cosine, right? So when I just write down cosine square of x plus sine square of x, wait, that's equal to 1. So all that work for 1. University of Chicago is actually one of the best schools in the world. And they have this question that's super cool. And they come out just like, oh yeah, the answer is a really nice answer, just 1. Usually they come out expression. Usually they come out as like something plus something. Okay, so I'm gonna give you a try. I'm gonna let you try. Yes. Uppercase. Remember the picture I sent you? The picture of a chicken.
The chicken.
Yeah, I do. All of them.
Oh, somebody told me that's not actually a chicken. It's supposed to be a duck because I look like a duck rather than chicken. But I don't know. I'm vegetarian, so I don't know. Oh, I'm Chinese. I only eat dogs. I don't eat chicken. That's really bad.
What's your favorite Chinese one? Yeah. That's a chicken. Oh, well, the cooked one is not.
Yeah, it is.
Who told you the dog? That's a chicken.
That's a chicken?
Oh, yeah. That's a dog.
Well, I never had it. I don't know.
All right, so we have an f of x. It looks like this. And we have the boundary is looking like square root. Wait, hold on a second. This is square root x, and this is sine of x. What?
You got me chatting
I have no idea who that is. All right. So we have this function, and we says, hey, can you take a derivative of this function? Now, at the end, this one doesn't work out like it end up to be a number. It's gonna get some type of expressions. What?
You said this is going to be on the test.
Yeah.
So then.
What time we get off?
8 minutes.
8 minutes? If you got it done, I have the answer right here. You can check. The answer is gonna be expression. It's not gonna be a number like last time.
Crap.
Is x, but that's fine. You have so you cannot have t and x, so they are x,
But yeah,
and this cosine is taken x. Yeah, that's fine.
I just
That
have to factor out the
put-
Holy shit.
No, I think we did it.
This is the answer. The answer will
Oh my
be
god, I got that.
1 over 2 root x times 1 minus x minus secant of x.
Can we all combine it? I like multiply this.
You don't have to. Maybe it's factor form.
But
I
then
always
it's
prefer factor
2
form,
over x.
not 2 over x.
Well, because we should 2 over x times 1.
That's x root x.
Huh?
If you distribute it, it's 2 root x minus 2 x root x. So it doesn't simplify down.
Wait, but I put it like this. Is that not right?
Yeah, but it's 1 over that.
Yes, it's 1/2 plus 1. So it'd be 3 over 2. And then this is the root, it's just half. So
Yeah, but those two does not subtract each other. They're different powers.
I thought you could combine these.
You can, but you can. It's not multiplying. It's subtracting.
So I just leave it like that.
Yeah, it's
Oh, okay.
subtracting.
Well, I got that.
I think I lost it.
You can just cancel these. You can just cancel these, right? You can find out cosine.
Did you dig it? Oh, I remember you cried. You don't like that?
Oh, it's the graph.
It doesn't matter how it's
It's like, go ahead.
It can be lost.
Oh no, you integrated for oh shit.
You are so late.
I got it.
1 over cosine square of x times cosine of x equal to secant of x.
1 over cosine squared of
Yeah.
Mhm.
That's what goes back. Yeah. So then it's just any